Hi, welcome back to our second video for 3.5, transformations of exponential functions. In this example, we are going to look at stretches, compressions, and reflections. So it says graph each function using transformations of the base y equals 4 to the x. So here's our base graph. We're going to mark some points off on it, and then we're going to use it to attain those here. So let's just switch this over to purple here. This graph is y equals 4 to the x. And I do have some points. I know there's the point 1, 4. I know this graph does kind of keep going up and through. We have 0, 1. And that's only 2 points. If I try to use x as 2, it's going to be 16, which is going to be somewhere way up here. I don't really want that. Let's use ones that are on the graph. So right here. So I know this is when x is negative 1. So if I put that into the equation, I would have the point negative 1. And remember, 4 to the negative 1 just means 1 over 4. So it basically means a quarter. Negative 1, a quarter. So I got 3 nice points. I will be transforming those points to get the new graphs. We'll do the first one in red. So y equals 4 to the x is being mapped over to the new one, y equals 4 to the 2x. So you've seen a couple examples like this in the homework for 3.4, maybe even in 3.2 or 3.1. So we know it does affect the graph. And I can also see that 2 is being multiplied by x. So whenever x is being multiplied something, it always means it's k, whether it's being multiplied or divided. So here we have k equal to 2. Therefore, we have a horizontal. This is going to be a compression by factor 1 over k. So k is 2, so it's by factor a half. I use the word compression because the factor is 1/2. All right, so we have our base points that we're going to use. So that was negative 1, a quarter. We had 0, 1, and we had 1, 4. So all those get mapped over to new points. So it is a horizontal compression, so we're going to be dividing x by 2. And the y values stay the same. So this will become negative 1 over 2 is negative a half, comma, a quarter. 0, when I divide 0 by 2, it's still 0, so that point is unchanged, it's invariant. And 1, 4, if I plug 1 in for x, 1 divided by 2 is positive a half, and the 4 stays the same. So I wrote them as a decimal. You could leave them as a fraction, it's fine. We're just trying to use it to obtain the graph. So negative a half, a quarter, that will be right here. It's the same height as the purple one, but it's at negative a half, about halfway through. Okay. 0, 1, that point stayed the same. And then we have a half 4, that's up here. So you can see it looks like the purple graph has been squished horizontally because that's the kind of transformation that this is. So it's going to go up through there and then up here. So this grows a lot faster than the base because the exponent is basically being double. One way to think about this algebraically is that this is actually the same thing as this. Right? If we apply the power rule, we got to multiply the exponents together. So this is like the base function squared. So it's growing a lot quicker. That's why we say it's been horizontally compressed, and we can see it. It actually grows much, much faster than the purple base one. Okay, so that's the first one. That was A. We'll do B in a different color. We'll do this one in blue. So my base graph is now mapping over to, y equals negative 2 times the base function. So whenever you multiply the base function by a quantity, it means it's a vertical shift or compression. So basically this is our A value, right? So therefore, it's a negative, first off. So we're going to have a reflection along x-axis. And we also have a vertical stretch by factor A. So it'll be by factor 2. Okay, you don't need to write the negative in. So what does this mean about our point? Well, the base points, if it's reflected in a vertical stretch, that means x stays the same. Everything's just y that's going to change. So when we reflect along the x-axis, y becomes negative. And also, we're multiplying it by 2, so it'll actually be negative 2 times y. All right, now all my points, negative 1, a quarter, 0, 1, 1, 4. Those all map over to the x's stay the same. And a quarter times negative 2 gives me negative a half. 1, when I plug 1 into here, I have negative 2 times, or so I have 1 times negative 2, which is negative 2. And if I put 4 in, negative 2 times 4 is negative 8. Let's go ahead and map those or plot those. So negative 1, negative a half, that'll be here. 0, negative 2 is here. And 1, negative 8 is here. So this is really interesting. So I want to graph this. It's good. It's kind of good to pay attention to what's happening here. So notice in these examples, we're only doing stretches and compressions. That means my HA is never going to change. It's going to be untouched because if you multiply the y values by a number, well, the HA is the equation y equals 0. So 0 times anything is going to stay. So this actually stays put, which is really nice because it helps me do all these other graphs. So notice I followed it with the red one. And now with the blue one, I got these 3 points. If I want to know what to draw, I got to make sure I don't do anything like this, right? Or this even. I want to show that this keeps following the HA. So it's important to know that. So I'm just going to draw this here. The HA is invariant when you have stretches and compression. It can only change with a vertical shift. All right, so let's go here. We'll graph that like this. Okay, make sure you have your arrowheads on there, and then you can write the equation, negative 2 times 4 to the x. Okay? When people see this equation, they might get confused. They might think they can multiply these two together, to just make this negative 8 to the x. You can't do that. This basically just means the base function 4 to the x, and then times negative 2. So we always have to apply BEDMAS rules. You can never multiply to get a new base when you have an exponent. Okay, and the last one, we'll go with green. Y equals negative a half x. So that's my exponent this time. So y to the 4x is going to turn into y equals 4 to the negative a half x. Yeah. So my x is being multiplied by another number again. That means it's k. K equals negative a half. Well, what does that mean? Well, it first means we're going to reflect, because it's negative, reflect along the y-axis. Okay, we reflect along the y-axis. And also, if k, the absolute value is between 0 and 1, which it is, it's a half between 0 and 1, then we're going to have a horizontal stretch by 1 over k, so by 2 units. So 1 over a half, which is actually equal to just 2 units. Or sorry, by factor 2. Okay, I usually don't write this in here. I like to just write it right here by factor 2. I just wanted to show you where it comes from. 1 over a half is 2. All right, so my base points for xy, which are negative 1 a quarter, 0, 1, 1, 4, those all map over to this time x is changing, so remember it reflects, so it becomes negative, and it's being stretched, so it's going to be negative 2 times x. And our y value remains the same. So negative 1 times negative 2 is 2, so I'll have 2 a quarter. 0, 1, well 0 times negative 2 is still 0, so that point's unchanged. 1, 4 becomes negative 2, 4. So 2 quarter and 0, 1, and then negative 2, 4. We can draw this like this. Get our arrows on there, just label the graph. Y equals 4 to the negative half x. So that one was reflected and horizontally stretched. And so that's basically how you take care of the transformation. So now at this point, we've covered horizontal and vertical shifts. Now we've covered the stretches, compressions, and reflections. That's it for this video. I'll see you in the next example.